guys, we're on our final installment of the notes for January 5th. We are on problem number 22. We've got another negative exponent here. Everything's raised to the negative 2 power. I'm going to show you a slightly different way of doing it than we did on our last negative exponent. This one I'm going to mess with the negative part first. So if we have a negative exponent, remember we put everything on the top, on the bottom. If it was on the bottom and it was negative, we put it to the top. So first I'm going to deal with the negative exponent by flipping my fraction. So I'm going to put 3y cubed on top, all over x squared on bottom. And now that's going to be raised to a positive 2 power. So all I did was flip it to get rid of the negative part of the exponent. And now I'm back to problems just like the rest of them. So this is going to be 3 squared over y cubed to the second power, all over x squared to the second power. 3 squared is going to be 9. Y cubed raised to the second, sorry about the equal sign. Y cubed raised to the second power. I'm raising a power to a higher power, so I'm going to multiply these guys. And that's going to give me y to the 6. On the bottom, I've got x squared squared. Again, multiplying those exponents 2 times 2 is going to give me 4. All right, on number 23, we got 3x to the 5th over 7y squared raised to the 3rd power. So I've got 3 cubed over x to the 5th cubed over 7 cubed times y squared cubed. So 3 cubed is going to be 3 times 3 times 3. That'll give us 27. Raising x to a higher power, I've got x to the 5 times 3, which is 15. On the bottom, I've got 7 times 7 times 7. I don't know that off the top of my head, so I actually had to use a calculator. And I got 343. And then y squared raised to the 3rd power would be y to the 2 times 3, which is 6. And I'll answer there. Number 24, this is one of those tricky problems again where we got 2 parts. So let's first deal with what's in the parentheses. So we've got 3 squared. I'm going to start cutting out a couple of steps there, see if you can keep up with me. So I've got 3 squared. That's going to be 3 times 3, which would be 9. And then I've got x to the 3 times 2 power, which would be 9x to the 6. On the bottom, we've got to square that 2. So 2 times 2, 2 squared is going to be 4. And then y squared. All over 1, or sorry, all times 1 over x squared. Now we're going to go ahead and multiply. These are fractions, so we're going to multiply straight across. We end up with 9x squared times 1, which is 9x to the 6 times 1, which is 9x to the 6. On the bottom, I've got 4. X squared, y squared. I wish I could say we were done, but we still have x's on the top and x's on the bottom, so we've got to deal with that. So if I've got x squared divided by x to the 6 divided by x squared, that's going to be x to the 6 minus 2, which is going to give me 9x to the 4th on top. On the bottom, my x's are gone now, and I just have 4y squared. All right, number 25. We're going to start again with our parentheses and start by cubing that guy. So I've got 2 cubed, x cubed, all over y cubed. And all that's going to be multiplied times 1 over 6x cubed. So 2 times 2 times 2 is going to be 8. X cubed is going to be x to the 3 times 3, which is 9, all over y cubed. That's going to be multiplied times 1 over 6x cubed. Again, let's multiply straight across. 8x to the 9th times 1 is just 8x to the 9th. And then I've got 6x cubed times y cubed. Again, we typically write it in alphabetical order, so your x's are going to be written before your y's. But we've got x's on the top and x's on the bottom again. So we gotta take care of that. I've got 9 x's on top, 3 x's on bottom, so 9 minus 3 would give me 6 x's on top. The x's on the bottom are gone, but I still have y cubed down there. And then while we're at it, I've got 8 divided by 6, and I can reduce that. 2 goes into 8 and 2 goes into 6. So 2 goes into 8 4 times and into 6 3 times. So that would be my final answer. All right, number 26. I'm going to leave this 3 over 8m to the 5th alone for a minute. And first work inside my parentheses. All right, we've got m to the 4th raised to the 3rd power. So 4 times 3 would be m to the 12th. In the denominator, we've got n squared to the 3rd power. N to the 2 times 3 would be n to the 6th. Again, we got a fraction. We're going to multiply straight across. So I've got 3 m to the 12th. On the bottom, I've got 8 m to the 5th times n to the 6th. All right, we got m's on the top and the bottom, so we need to take care of that. We're dividing our m's, so we're going to subtract those exponents. Let's put our 3 in, our 8 in. We got m to the 12 minus 5. 12 minus 5 would be positive 7, so it's going to be on the top. On the bottom, I've got n to the 6. I guess we didn't need all that fraction bar. So, last problem. I'm going to challenge you. This is a hard one, but pause the video, see if you can figure it out, and come back and see if you got it right. All right. If you're back with me, we've got negative 5 squared over x squared. On the other side, we got 2 squared. And then we got x to the 4th squared, all over y cubed squared. So negative 5 times negative 5 is 25 over x squared. On the top, I've got 2 squared, which is 4. X to the 4 raised to the 2 is 4 times 2, which is 8. On the bottom, I've got y to the 3rd raised to the 2nd power. Y to the 3 times 2 is 6. Putting these guys together, we've got 25 times 4, which is 100. X to the 8 on top. On bottom, I've got x squared, y to the 6. Once again, I've got x's on the top and the bottom, so we want to get rid of the x's on the bottom. So I've got x to the 8 minus 2, dividing fraction, or dividing my x's, dividing my bases, so I need to subtract my exponent. So I got 100. Oops, that doesn't look like an x. Let's try that again. 100x to the 8 minus 2, which is 6. And so no more x's now on the bottom. We just have y to the 6 on the bottom. So that is it. Again, questions, please send them to me through Canvas. I'd be happy to help you over the weekend. And I hope you're enjoying your weekend. I'll see you on Monday. Your homework is due on Monday. Have a great weekend.